0.75 divided by -3 is -0.25. 6 divided by 3 is 2. 6 minus 10 is -4. Okay, with this, I just tried to think of, okay, if I took 1.5 away from both sides, we get 10 times something equals 6. Well, that would be 0.6. Okay, 2 feet squared, or square feet into square inches, would be 2 times 12 times 12. 2 times 144, we get 288. Okay, in this case, we're looking for 66 2/3%, which is the fraction 2/3. 2/3 of 2400. 1/3 of 2400 is 800. So 2 of them is 1600. So 2400 reduced by 16 2/3%, or reduced by 2/3, is 2400 minus 1600. Or you can think it's being reduced by 2/3, so what's left is 1/3, which was 800. All right, now this one I would really like you to have your book open and look at the pictures that they provide, because I didn't do all the pictures and they have some stuff added in this lesson that I'm not covering on video, okay? And I'll tell you what to look at. So there are pictures of 3 different pyramids in the book there. A pyramid has a polynomial base and it comes up to a point, okay? And the volume of a pyramid is 1/3 of the volume of a prism, okay? So I'm going to tell you, remember when our volume of a prism, prism, will equal to the area of the base times height, right? Well, the volume of a pyramid is just 1/3 of the volume of a prism. So it's 1/3 area of the base times the height, okay? So we're going to use this formula and find some volumes here. Now, there is a very faint, hopefully when I do this, when I photocopy these, it'll come out. But there's a faint little prism within this cube here, right? And it's a 6 by 6 cube. We're going to find the volume first of the cube, okay? So again, the volume of that equals area of the base times the height, okay? Well, the area of the base is a 6 by 6. So it's 6 times 6, and then the height also is 6 because it's a cube. So the volume of the cube is 6 times 6 times 6, which is 36 times 6, which is 216 centimeters cubed, okay? And then they said find the volume of the pyramid. Well, we're going to use the formula, or we could just do 216 divided by 3, right? Because I just told you it's 1/3 of the area of a prism, okay? So let's use the formula though and get used to that. Volume of a pyramid, I'm going to say volume of a P equals 1/3 times, we're going to say volume. They're letting us do this. Volume of the prism. Okay, so that equals 1/3 times 216, which is 72 inches cubed. Centimeters cubed. Correction. Okay. Now, the volume of a cone is 1/3 of the volume of a cylinder, okay? This volume of a cylinder, it's a circle bottom, right? A cone is the same, it's just the bottom of a circle, and it comes up to a point. So it's 1/3 the area of the base times the height. Well, the area of the base happens to be a circle, so we get to use pi r squared in there, okay? And I know some of you don't get excited about that. Okay, so let's find the volume of this circular cone. Dimensions are in centimeters and use 3.14 for pi. Okay, let's first use volume equals 1/3 area of base times height. Okay, let's write the formula. You can write it out that way if you'd like. And then we're going to plug in what we know. 1/3 area of the base is pi r squared. But do we know our radius? Oh, I'll give you 2 levels to do this. Pi r squared, and the height is 30. So now let's plug in our radius. 1/3. Our radius is 10. Okay. Our diameter is 20. So I'm going to say 100 pi times 30. Now I'm going to do some cross canceling though. 3 goes into 30 10 times. So now what I have left is 10 times 100 pi. So I get 1,000 pi. And then it says multiply that by 3.14, right? And so when we do that, we get about equal to 1,000 times 3.14. Now that's nice because it's a multiple of 10. So that means we just move this decimal over 1, 2, 3 times. So that's about equal to 3,140 centimeters cubed. I like it when they're nice like that. We didn't have to do any side multiplication for that. Okay. Now is where I would like you to look in your book, page 792. They've got pictures to show you the special relationship between the volume of a cylinder, the volume of the cone, and the volume of a sphere. And they want you to notice how those came about. Okay. The volume of a cylinder is the area of a circle times the height, which is pi r squared h. Okay. And they show you where we get 2 pi r cubed. And so I want you to look at that just on page 793 and how they come up with 4/3 pi r cubed for the volume of a sphere. Okay, I want you to really look at that. And we're going to use the volume of the sphere to do example 3. Okay. A ball with a diameter of 20 has a volume of how many cubic centimeters? Okay, so we're looking for volume. All right, so let's go ahead and say volume equals 4/3 pi r cubed. Round the answer to the nearest 100 cubic centimeters, and we're using 3.14 for pi. Okay, so really all we need to put in there is our radius, but let's do this. Yeah, 3.14 for pi, and then our radius. Well, our diameter is 20, so our radius is 10 cubed. Okay, so now let's deal with the exponent first. Order of operations, we got 4/3 times 3.14 times 1 with 3 zeros, 1,000. Okay, and we can first multiply these two together, right, and see what we get. We get 4/3 times, and we're going to move that decimal over, so we got 3,140 again. Okay, and that will not work out perfectly for us, but we're going to round to the nearest centimeter. So how we're going to do this is, what I'm going to do is go, okay, 3,140 divided by 3 first. Or we can multiply by 4. I'm dividing by 3 first. Okay, so again, I'm not afraid to practice my division. It's actually pretty good, pretty good exercise. And what happens is I get 1046 2/3. Okay, so we get 4 times 1046 2/3. And then we need to multiply all that by 4. Okay, and when we do that, I'm going to go ahead and do it. I'm not scared. 16, 18. I got 4,184. But then we've got 2/3 of 4. Okay, so add 2/3 of 4 to that, and that is going to be 4,186, 2 2/3 basically. I don't know if you get that. Maybe we should have multiplied that first and then divided. Okay, if we did that, that way you could go ahead and get 4,186 and 2/3 centimeters cubed, and then that's to the nearest cubic centimeter, though, is to the nearest 100 cubic centimeter. It's 4,200. Okay, so if you got all confused with what I did here, instead let's do 3140 times 4 and then divide that by 3, and we'll get this round to the nearest 100, and there we go. Okay, now you have your practice, so go ahead and do that. Check the answer key with your final answers, or come back and watch the video. Okay, so today here we have two identical, this is a cylinder, I don't know, it didn't come out as well, cylinders whose heights are equal to their diameters, okay? In one cylinder, the largest cone it can in one cylinder is the largest cone it can contain. In the other cylinder is the largest sphere it can contain. Packing material is used to fill in all the voids in the cylinders not occupied by the sphere. Use this information to answer problems A through E. Sorry I read that to you because I didn't even do a good job of that. All right, what fraction of the cylinder containing the cone is occupied by the cone? Okay, remember we said it's 1/3 of the volume. So the fraction of the cylinder taking up space, is by the cone is 1/3. What fraction of the cylinder containing the cone then is packing material? Well, it's the other 2/3. Okay. What fraction of the cylinder containing the sphere is occupied by cylinder containing the sphere is occupied by the sphere. Okay, now remember what we read on page 793, it's 2/3 of the sphere is the cylinder. Okay, or sorry, 2/3 of the cylinder is the sphere, and that means 1/3 would be the empty space. Whew, my tongue tied. All right, if the cone and the sphere were removed from their boxes and all the packing material from both boxes were put into one box, what portion of the box would be filled with packing material? Okay, so packing material in the first one was 2/3. Packing material in the second one was 1/3. So we get 3/3, so the whole box. Okay, let's move on. See if I can read these correctly. So we have a cube and we have a pyramid in that cube. What is the volume of the box? Okay, I'm going to say volume of the box equals, remember we can do length times width times height, or area of the base times height. Okay, which is 12 times 12 times 12. Okay, so 144 times 12 is 1,728 inches cubed is the volume of the box. Okay, now the volume of the pyramid is 1/3 the volume of the box. I'm going to write 1/3 volume of the box. So what we get is 1/3 times 1,728, and when I do that, it comes out nice and neat, and I get 576 inches cubed is that pyramid. Okay, now we're going to find the volume of each of the figures. Okay, we've got a cone and a sphere. So remember, the volume of a cone is area of the 1/3 area of the base times the height, right? So we're going to say volume equals 1/3 area of the base times the height, or basically 1/3 the area of a cylinder. Okay, so we got 1/3 area of the base is pi r squared, and the height is 6. So we're going to and it says leave pi as pi. That was nice. So the radius is 3 squared times pi times 6. I separated them all out. Okay, well that goes 1/3 1/3 times 9 times pi times 6. And then it looks like we can do some canceling out. Okay, 3 goes into 9 3 times. So we get 18 pi. And I don't have to do about equal to 18 pi since we're leaving pi as pi. So about 8, so for sure 18 pi inches cubed. Okay, I love it when we get to leave in terms of pi. Okay, now the volume of a sphere equals 4/3 pi r cubed, right? So that equals 4/3 pi times 3 cubed. Equals 4/3 pi times 27. Okay, and these will cancel. So 4 times 9 is 36 pi inches cubed. Okay, there you go.